This absolute value inequality is pretty much like the exact one we just finished. One difference being that it's a greater than instead of a less than. And I use the same steps we used in section 1.3 to get this down to here. And just as a quick reminder, for all these steps, I'm kind of thinking of the original problem as if it were something like this. And whatever steps I take to solve this, those are the steps I'm taking to get this absolute value bar all by itself. And now we have the greater than instead of less than. And it's the same thought process, just different results as last time. This time I want to know which numbers will work. Well, that's the same. But this time it's which numbers have an absolute value that's more than 3. So numbers whose absolute value is more than 3, that'd be things like 4, or things like -7, or things like -10, or things like 8. You know, this absolute value is more than 3. This absolute value is more than 3. This absolute value is more than 3. You get the idea. The numbers that don't work are the numbers like 2, or -1, or -1.5. This absolute value is not more than 3. This absolute value is not more than 3. This absolute value is not more than 3. So basically, last time when it was less than, we wanted all the numbers that were between -3 and 3. This time, we want pretty much everything else, meaning we want all the numbers that are not between -3 and 3. We want all of these and all of these to solve over here. So the only way to do that is with what we call an OR statement. We want the numbers that are more than 3, or the numbers that are less than -3. So it's got to be something like this k minus 4 either has to be, oops, that's a mistake. This k minus 4 has to be more than 3, or the k minus 4 has to be less than -3. And if I solve both of those inequalities, I'm going to find all the numbers that live over here, all the ones that are more than 3, and all the ones that are over here, less than -3, that satisfy this expression. And now solving from here is your Algebra 1 type stuff. Keep in mind these are inequalities, so if you ever do divide by a negative number, the inequality flips directions, but that's not a problem here today. So I'll add 4 to both sides. That means k is more than 7, or add 4 to both sides on this equation, k is less than 1. And then that would be my answer written out. You know, and if you, by the way, if you wrote it this way instead, k less than 1, or k more than 7, that would be equally correct. And if you had to actually shade it on a number line, it would look kind of like what I have up here, but it'd be different numbers. Those would not be the numbers. It'd be a 1, and an open circle, and a 7, and an open circle, and we'd shade to the left of the 1 and to the right of the 7. And finally, if you ever have any doubts if you're correct or not, you could pick any number from this region or this region, plug them into the original problem, and see if it actually works. So pick like maybe like a 10, or pick like a 0 and plug it in here, and like evaluate this, and you'll see that once you finish it, the answer is more than 10. All right, good luck. If you have questions, email me, or try to like look at the videos again and figure out specifically what your question is, and we'll talk later. All right, bye.